Hello, academic stars on the grid. Welcome back to Caltex Academic SNU. My name is Julius and thank you for joining us today. On our board, we are looking at question number 6 from Kumba University, Uganda. If you missed the previous questions, I've linked a card could be popping up somewhere here. You can go ahead and also watch before you continue with this question here. And if this sounds great, come closer, let's dive into the video. Don't forget to subscribe to the channel. So we have 4 parts of this question. Question B, number 1 is about product rule, and question 2 is on chain rule. We also have some product rule here, and also quotient rule. So the 2 questions on product rule, one from chain rule, and the last one is quotient rule. So let's go on and start with question B, Roman number 1. Now in this question, we are given a function here, and this function is f of x is given by, in a bracket, 3x plus 4. We multiply it by x cubed minus 1. When we're using product rule for this kind of question, we can let the first bracket to be u and the second bracket to be v. Now, let's differentiate u with respect to x. Firstly, we can write it out like that, and also the other one here, we can write it v corresponding to x cubed minus 1. We start with u, so we are differentiating u with respect to x. Therefore, du by dx will be given by, remember, when you are given any function y is equals to x to any power n using power rule, our derivative y prime, or we can write in this form, is given by, we multiply this function by n and we reduce that power by 1. So using this power rule, we can apply it here, and we have the power for this is 1. So 1 times 3, we still get 3. And therefore, the power has been reduced by 1, meaning 1 minus 1 is 0. Anything to the power of 0 is 1. So 1 times 3 becomes 3. And the derivative of a constant 4 is 0. So for that case, our derivative du by dx is only 3. Let's do the same to the second one here, and we have dv with respect to x. Therefore, we also multiply by this power here, and that is 3x, and we drop this power by 1, and 3 minus 1 is 2. Also, negative form is a constant, its derivative is 0. So you simply write that. Now, since we've already differentiated the 2 parts, u and v, we can now move on and get the derivative by quoting our formula first. So we can say the derivative function f prime x is given by, we can start by u or v, it doesn't matter. So v multiplies du by dx plus u multiplies dv by dx, and that is the formula for product rule. And from there, we can make substitution. Our v in this case is here, and we have x cubed minus 1 multiplies du by dx is 3. And since it is 3, I can decide to bring it from here, and we have here 3 plus u is this function here, that is 3x plus 4. Again, times dv by dx, and dv by dx is this function. We can again bring it from here, or you can write it here. It doesn't matter if you want to fill the order, and you have it here as 3x square. Now here we bring it from, and I have 3x square. So the next thing left here is to simplify these functions, and we have the derivative of x will be, opening up this bracket, we obtain 3x cubed in our first term, and the second term here is 3 times negative 1 is negative 3. Currently, by the second term here, we multiply this, either 3 is 9, and x squared times x, we get x cubed. So we use the second term also, 3x times 4, we get 12x squared. Now, since we have 2 terms here that are having the same power, then we can also reduce it down by adding them. So the derivative function is given by, when we add 3 to 9, we get 12. So we have here 12x cubed divided by our 12x square. Now here we have descending powers of x, and we have only one constant here, and that is negative 3. And this gives us solution for the first question. I hope you enjoyed the video, and if so, please subscribe to the channel. And let's move on to part 2 of this question. Alright, in part 2, we have this question which there has to use chain rule. Now, from here, we can first of all take what is inside this bracket and replace it by another variable, say u. So, if that is the case, we have our u here equivalent to what is inside there, that is negative 4x to the power of 5 plus 5. And from here, we can replace our bracket here with our new variable u. Therefore, y will be equivalent to 3 all over u, but remember this was raised to power 15, so we have also u to the power of 15. Now, to make it simple also, we can take this denominator up to the numerator here if a power or exponent crosses a bar or division sign, then the sign will change from positive to negative. If it was negative, it will also change to a positive. So let's go ahead and do that. Now we are not started differentiating, but we're only trying to arrange it to make it more simpler. So here we have our u, and here the power has changed from positive 15 to negative 15. And from here, we can go ahead and start differentiating y with respect to u, because the variable here has changed to u from x. Here we can say dy by du is given by, so firstly, using the power rule, we multiply by our power here, and we have negative 15 times 3. We can use our calculator here, 15 times 3, we get 45, so we can write here negative 45, and this multiplies u. And now, according to the rule also, we have to break the power by 1. So minus 1 is like negative and negative together added. So we have here minus 16. So for that case, that is the derivative of y with respect to u. Now let's get back here and also differentiate u with respect to x. So we have du by dx. This is equivalent to, multiplying this, we get negative 20x, and we drop the power by 1 to 4. And the derivative of a constant is 0. So for that case, we end here. Now since we've gotten two of these expressions, now we can move on and combine them together to get our derivative function. So our derivative function is using chain rule. We can have something like dy by dx, because the original function was in terms of x. Now this is given by our function here, derivative dy by du times the next function here, du by dx. So when you look at this one carefully, this one is the same, u and u, meaning if you cancel, you will get dy by dx, which is the left hand side exactly, and that is what chain rule says. So for this case, let us go on and substitute these values, dy by du as negative 45, u exponent negative 16, and multiply this by du by dx, which is negative 20x exponent 4. Before we make our substitution for u, let us first simplify this. So negative times negative is 40, and we have 45 times 20, that is 900. And from here, we can attach our x to the power of 4 here, and we are left with u negative 16. And again, it's good to have this exponent positive, so we can drop it down. If you wish, you can continue writing here our dy by dx for it to look more consistent. So at this stage, we are dropping down our function here with u exponent 16. So we'll have 900 x exponent 4 all over u exponent 16. Earlier on, we had a positive crossing up to become negative. This time we have negative in the numerator going back to the denominator, and it is a positive exponent. Now at this stage, we can go on and replace the value of u by what we let earlier on here, and that is u is given by this function here. So negative 4x to the power of 8 plus 5 represent u. So we can place it back in that expression, and our solution will be done. So let's do that here. Or dy by dx given by 900 x exponent 4 all over into bracket negative 4 x to the power of 5 plus 5, and the exponent here is 16. So that becomes the solution for the second part of this question here. Now, if you're enjoying the video, you can let us know by writing a comment in the comment section to see how you have gone with this question. Let us move on to the next question, and that is part 3 of the question. Alright, from this question, as usual, we can let this one here to be v, and here we have v, meaning when you extract it out, v is equivalent to x to the power of 4 plus 4 x squared, and our v is equivalent to x minus 6x to the power of 4. So we can go on and differentiate the first function here, the v with respect to x. Now when we do that, we can lower this power down, and we have to multiply by x, reducing 4 by 1 to 3. The second term here, we can now also this 2 down, and becomes 4 times 2, that is 8. Then the power will drop by 1 to 1. And we're done with the derivative of the first part. Now let's move to the second part. We are differentiating v with respect to x. So we have the v by dx equals to the power is 1, multiplying this x will remain as x, so we can also drop the power by 1, and that becomes 0. So anything to power 0 is 1. So therefore, this first part here is 1. Now we move to the second one. Here we drop this 4 down to multiply 6, and we get negative 24. Then here we have yx, and the power has to drop by 1 to 3. Now from here, that's the second derivative, and lastly we need to combine all this together to get our derivative in terms of y with respect to x, since our functions are in terms of x. So let's do it down here, and we have dy by dx. We studied this formula before. We said v, this time we'll start by v, they're all the same. So we have v times dv by dx. We are adding it together to v du by dx. So putting in the substitution, we will have our dy by dx as the value for u is x plus 4x squared. Dv by dx is this function here, and that is 1 minus 24x cubed. And that is the first part here. We move to the second part. Now let's place in our addition sign here. And we have the next one is v, and our v is this function that is x minus 6x cubed. And here we multiply by du by dx, and our du by dx is a function here, and that is 4x cubed plus 8x. So let's go on and make simplification by opening up those brackets. Now we multiply this bracket by the first term here. So we have x to the power of 4 multiplied by 1. Here we have x to the power of 4. So x to the power of 4 times 24x cubed, we get minus 24x. So when we multiply numbers with the same basis, according to indices, the powers will add together. So we shall have 4 and 3 added together to 7, and that is the power for the combined x being multiplied together. Now we are done with this term. Let's move to the second term. This multiplies 1 will remain the same as 4x square. Let's go to the last one here. So we have 4 times 24, that is, let us use a calculator quickly, and we have 24 by 4 giving us 96. So this is negative 96, and here we have x to the power of 2, here we have x to the power of 3. Since we multiply, we add the powers together, and we have x exponent 5. So we are done with this first part, and we move on to the next part here, and let's bring in also our additional sign to separate the two terms, this one and that. So from here we are multiplying this x by that will remain the same thing as 4x, but the power here will reduce by this 1 to 4. So we move on to the next one. We have here plus 8x. This power will increase to 2. So we have here square, and we're done with this first part. Let's move to the second part, multiplying these two terms. So this one becomes minus 24x. So the power will also go to, sorry, this one was power 4, not 3. So let's move on and do this expansion. So we have, now this one goes to 7, and let's move on to the next one here. Negative times 4, 6 is negative, and we have 6 times 8, we get 14. 8 and x will increase this one to 5. So from there, we can move on and simplify these terms with the same exponent, and we have our dy by dx is given by, we can start with this one with small exponent. So they are positive, we can add them together and we obtain 12x square. So let's move to the next one is 4. Now we have here 1, then we have here 4, making 5. So we have plus 5 exponent 4. Let's move to the next one, that is 5. And for 5 we have negative 96 and negative 48. We can sum all this together, 96 plus 48, 144. So we have minus 144x to the power of 5. And lastly, we go to power of 7. We have here negative 24, negative 24. This one adds together to make 48x to the power of 7. I think is the highest power here, and we'll reduce it to these 4 terms. So that becomes solution for the third question. Now with all this, let's also move on to look at the last question on quotient rule. Alright, in this last part of this question here, we have been given this, and we'll take the first part here to be our u, and the denominator to be our v. So putting this one down, we'll have u is the same as x square plus 1, and we can differentiate u in respect to x. So from here, we also do the same like before. We multiply this by 2, and that is x, and reduce the power here by 1. So 2 minus 1 is 1. So e to the power 1 is itself. And the derivative of this constant 1 is 0. So for that case, that is the derivative of the numerator. And for the denominator, we say v is the same as this function here, and that is 3x minus 5. Again, let's differentiate v with respect to x. We have the v by the x as here we multiply by 1, and that is the same thing. Reduce that 1 by 1, it goes to 0. Anything to power 0 is 1, and 1 times this 3 remains the same as 3. Remember, a constant goes to 0. So I finish differentiating these parts individually. Now for quotient rule, it is set like this. So let's put it down before we start solving it out. Now we'll have the 1 by dx is given by, now we always start with v, and we multiply this by du by dx, not like in product rule where we can interchange u and v to u. So for that case, here we subtract u term is dv by dx, and we divide the whole thing by v square. So that is the quotient rule. So let's move on and make our substitution. Here where we have our dy by dx, this is the same as, so v is this function here where we can give it as 3x minus 5, then dv by dx 2x. So we can bring it here and say this is our 2x. Then we subtract, and this subtraction is what we have here. Perhaps I can put bracket here, and we have x square plus 1. So we multiply this by dv by dx, and our dv by dx is just a number here that is 3. So we can place it around there and we close our bracket. And remember, we have to divide the whole thing here by our v squared, and v is this function here. So let's go ahead and write it and square, and that is 3x minus 5. So is to be squared. Now let's move on. So from here we have dy by dx is given by, now here you can open up this bracket by multiplying by 2x here. So the first term goes to 6x squared, and the second term goes to 10x. Now we're done with this. Let's move to the next one here. By maintaining this bracket still, we can go on and open up this bracket by multiplying it by 3. So the first term goes to 3x squared. The second term goes to 3. Plus 3 times 1 is that 3. Then we divide this by the denominator, and our denominator we can go on and expand. So I'm using shorthand here with this expansion where we square the first term and we square the last term. Then the term in the middle, we multiply this 3 terms together. So let's start by squaring the first term. If we square 3x, we get 9x squared. And multiplying all these terms together, 2 times 3 is 6. 6 times 5, we get 30, but negative. So we have negative 30x. And squaring the last term, we get 25 positive. So let's open up the numerator and see how it simplifies to. So y by dx is given by, the first term is already okay, 2x minus 10x. When we open up that bracket, we have 3x squared minus 3. And this is divided by 9x squared minus 30x plus 25. Now from here, we can simplify these two terms. Again, we can rewrite the next step here, and we have dy by dx is given by, so subtracting this 3x squared from this 6x squared, we get 3x squared, and here we have minus 10x, and here we have minus 3 all over 9x squared minus 30x plus 25. This is where I'm ending with this simplification, but you can go ahead, since this is the important fraction, you can divide the numerator by denominator, or you can factorize it out and have it in the simplest form. But for now, this is an answer that you can also take. And if you have watched up this time, thank you very much for watching. Please support this channel by subscribing to the channel, share this video with friends so that it goes to many audience. And thank you very much. See you in the next video. Peace out.